A lithium-ion battery weighs only a few hundred grams. That's it. The object powering your phone, your laptop, your wireless earbuds, and increasingly your car can fit in a backpack. Yet entire governments are suddenly treating it like a national security asset. That should tell you something. For years, discussions about global power revolved around oil fields, aircraft carriers, semiconductor fabs, and rare earth minerals. Meanwhile, one of the most important industrial shifts of the century was happening in plain sight, factory by factory, refinery by refinery, supply contract by supply contract. Most people never noticed. Then reality arrived all at once. American officials began asking a question that sounds surprisingly simple. If the future runs on batteries, who actually makes the batteries? The answer was uncomfortable. Today, China produces roughly 80% of the world's lithium-ion batteries. Not lithium, batteries. That's a very different thing. Plenty of countries have lithium reserves. Australia digs up enormous amounts of the mineral. Chile sits on vast deposits. Argentina has become a major supplier. Yet when those materials begin their journey toward becoming the battery inside an electric vehicle, a power storage system, or a consumer device, the path usually leads through China. And that's where this story becomes far more interesting than a simple mining discussion. Because the country that dominates a supply chain doesn't necessarily own the resources. It owns the process. Think about that for a moment. If lithium is the crude oil of the electric age, batteries are the equivalent of refineries, pipelines, chemical plants, shipping networks, and gas stations combined. Extracting raw material is only the beginning. Turning it into a finished product at massive scale is where the real leverage lives. China understood this years before most Western governments did. Back in the early 2000s, battery demand was relatively modest. Smartphones existed, but electric vehicles were still viewed as niche products. Many policymakers assumed battery manufacturing would simply spread across the global economy the same way countless other industries had. It didn't. Instead, China pursued a strategy that looked almost boring at the time. Local governments provided land. State-backed financing reduced costs. Chemical processing capacity expanded. Universities trained engineers. Companies were encouraged to scale aggressively, even when profits were thin. None of these headlines generated much excitement. A new refinery isn't as dramatic as a fighter jet. A battery materials plant doesn't attract the same attention as a semiconductor breakthrough. But industrial power often accumulates quietly. One factory becomes 10, 10 become 50. Eventually, competitors discover they're not competing against a company anymore. They're competing against an ecosystem. And ecosystems are hard to replicate. There's a reason many Western executives privately describe battery production as one of the most difficult manufacturing sectors to enter. Success isn't determined by a single invention. It's determined by thousands of small improvements across chemistry, logistics, processing, quality control, workforce training, and supply contracts. Miss one link and costs rise. Miss several links and the business collapses. The strange part is that warnings existed for years. Industry reports repeatedly showed China's growing control over battery refining, cathode production, anode manufacturing, and cell assembly. Analysts discussed it. Specialists understood it. Investors paid attention. Governments largely moved at a different speed. Then, electric vehicles started selling in serious numbers. Suddenly, every major automaker wanted batteries. Suddenly, energy storage became critical for renewable power grids. Suddenly, demand forecasts looked far larger than anyone expected a decade earlier. And suddenly, the question wasn't whether batteries mattered. The question was whether enough of them could be produced outside China. That's where the numbers become difficult to ignore. Because what appears to be a lithium story is actually a manufacturing story. And manufacturing stories tend to move slowly for years before becoming impossible to avoid. The deeper you look into how China built this position and why America is now spending hundreds of billions trying to respond, the more you realize this wasn't an accident. It was the result of decisions made long before most people understood what was coming. And one decision in particular changed the trajectory of the entire battery industry. The decision wasn't made in Washington. It wasn't made in Brussels either. A large part of the story traces back to Beijing in 2009, when Chinese policymakers identified electric vehicles as one of several industries where the country had a realistic chance to leapfrog established competitors. China knew it wasn't going to out-German Germany in traditional combustion engines. It wasn't going to out-Japanese Japan in decades of accumulated automotive expertise overnight. But batteries change the rules. When the game changes, experience becomes less valuable than timing. That realization shaped everything that followed. The Chinese government rolled out subsidies for electric vehicles, backed battery manufacturers, encouraged local governments to build industrial clusters, and created demand large enough for companies to scale rapidly. Firms like CATL and BYD emerged from that environment and grew into global giants. At the time, many Western observers dismissed the effort. The vehicles weren't particularly impressive. The technology wasn't revolutionary. The brands had little recognition outside China. Yet something more important was happening beneath the surface. Factories were learning. And manufacturing is often a learning contest, disguised as a technology contest. Every battery cell produced teaches a company something. A tiny improvement in quality control, a slightly faster production line, a better chemical formulation, a lower defect rate. None of these developments generate headlines. Together, they create enormous advantages. Imagine two companies building batteries. One produces 1 million cells, the other produces 1 billion. Which company learns faster? The answer is obvious. Scale isn't just about volume, it's about knowledge. By the late 2000s, Chinese manufacturers weren't merely making more batteries. They were accumulating experience at a pace competitors struggled to match. Costs fell, efficiency improved, supply chains became denser. And then another critical piece fell into place: refining. Many people assume lithium comes out of the ground ready for battery production. It doesn't. Raw materials must be processed, purified, and transformed through complex chemical procedures before they become useful battery components. This stage is less glamorous than mining and far less visible than electric vehicles rolling off assembly lines. Yet it's one of the most important links in the chain. China invested heavily in refining capacity, while many other countries focused on extraction. The result was remarkable. Australia became one of the world's largest lithium miners, but much of that material still traveled to China for processing. Similar patterns emerged across nickel, cobalt, and other battery materials. This created a strange global arrangement. Countries owned resources. China owned much of the industrial machinery required to transform those resources into battery-ready materials. Those are not the same thing. There's an old assumption in economics that markets naturally distribute production efficiently across multiple regions. Most of the time, that's true. Battery manufacturing didn't entirely follow that script. The reason is simple. Building a battery ecosystem requires dozens of interconnected industries developing simultaneously. Chemical suppliers need customers. Customers need equipment makers. Equipment makers need trained workers. Workers need universities producing specialists. Remove one piece and the entire structure becomes weaker. China didn't build individual companies. It built industrial neighborhoods. In some regions, battery manufacturers, cathode producers, anode suppliers, machinery firms, logistics operators, and research centers sit within relatively short distances of one another. Information moves quickly, components arrive faster, problems get solved sooner. That's difficult to replicate with policy announcements alone. One American executive joked that policymakers often think supply chains can be created by signing legislation. Factories tend to disagree. The humor works because there's some truth hiding inside it. Industrial ecosystems require years, sometimes decades. This is where the debate becomes more complicated. Critics argue China's dominance was fueled by subsidies and state intervention. They're not entirely wrong. Government support played a major role. Supporters counter that Western countries subsidize strategic industries too, especially when national security is involved. They're not entirely wrong either. The real question isn't whether governments intervened, it's whether the intervention produced lasting industrial capability. Looking at battery production today, it's difficult to argue that China failed that test. But before concluding that America simply lost this race, there's another piece of the puzzle worth examining. Because dominance in one stage of a technological transition doesn't always guarantee dominance in the next. And the battery industry may already be approaching its next major turning point. For a long time, the battery story looked straightforward. China was winning. Everyone else was trying to catch up. Case closed. Except reality rarely stays that simple. Because the deeper you go into this industry, the more you discover that today's leader is constantly vulnerable to tomorrow's chemistry. A battery factory isn't an oil field. Oil fields don't suddenly become obsolete because a scientist publishes a paper. Battery technology can. That's the reversal most people miss. China's dominance is real. It's substantial. It's measurable. But it sits on top of a technological landscape that continues to evolve. And history has a habit of punishing industries that assume the current formula will remain permanent. Remember the number from the beginning, roughly 80% of global lithium-ion battery production. That figure sounds overwhelming. Yet the phrase lithium-ion matters more than most people realize. Not long ago, cobalt was considered essential for many high-performance batteries. Then, manufacturers found ways to reduce cobalt content. Costs fell. Supply risks changed. A decade ago, many experts viewed certain battery chemistries as niche products. Today, they power millions of vehicles. The chemistry keeps moving, which means the real competition may not be about who dominates today's batteries. It may be about who dominates the next generation. That's where the United States sees an opportunity. Washington's response has become increasingly aggressive. The Inflation Reduction Act, passed in 2022, wasn't just climate policy. It was industrial policy wearing a climate policy costume. Billions of dollars were directed toward battery plants, processing facilities, mineral supply chains, and domestic manufacturing incentives. The objective wasn't subtle: reduce dependence, build capacity, create alternatives. Since then, companies have announced dozens of battery-related projects across the United States. States such as Georgia, Tennessee, Kentucky, Michigan, and North Carolina have become major battlegrounds for investment. Factories are appearing where cotton mills, tobacco warehouses, or traditional manufacturing plants once stood. Some projects are succeeding. Others face delays. Several have struggled with labor shortages, permitting challenges, and cost overruns, which raises a difficult question. Can industrial ecosystems be accelerated by government policy, or do they only emerge through decades of accumulated experience? I'm not entirely certain anyone knows the answer yet. The evidence points both ways. America has demonstrated the ability to build advanced industries remarkably quickly when incentives align. The semiconductor sector offers examples. Aerospace offers examples. Defense manufacturing offers examples. At the same time, battery production depends on thousands of operational details that can't simply be legislated into existence. A law can authorize funding. It can't instantly create 20 years of manufacturing know-how. Meanwhile, China isn't standing still waiting for competitors to catch up. That's another assumption that often distorts the conversation. Some analyses discuss China's current position as though it's frozen in time. It isn't. Chinese companies continue investing heavily in research, refining, automation, and new battery chemistries. Firms such as CATL are exploring sodium-ion batteries, technologies that could reduce dependence on lithium in certain applications. Think about the irony. Much of the world is trying to reduce dependence on China's lithium battery ecosystem. China is already researching ways to reduce dependence on lithium itself. Industrial leaders rarely survive by defending yesterday's advantage. They survive by creating tomorrow's. And there is a human story buried inside all of this. In Ningde, a city that most people outside China had never heard of 20 years ago, CATL grew from a regional company into the world's largest battery manufacturer. Thousands of engineers, technicians, researchers, and factory workers contributed to that rise. The lesson isn't that one company became successful. The lesson is that entire cities can be transformed when an industry takes root. A battery plant isn't just a building. It's suppliers, housing, universities, transportation infrastructure, small businesses, tax revenue, careers. The economic ripple effects spread outward for decades. That's why governments care so much about this sector. They're not chasing batteries. They're chasing industrial ecosystems. And this leads to a bigger question than China versus America. What happens when every major economy decides that strategic industries are too important to leave entirely to global markets? Because that's increasingly what we're seeing. The era of maximum efficiency is colliding with the era of maximum resilience. And those two goals don't always point in the same direction. There's a tendency to frame this entire story as a competition between two countries, China versus America. One wins, one loses. Simple. Except that's not actually how industrial history works. The countries that thrive during major technological transitions aren't always the ones that dominate the first phase. They're usually the ones that recognize what phase comes next. And that's why the battery story is still unfinished. China's position today is extraordinary by any reasonable standard. It controls huge portions of battery manufacturing, refining capacity, supply chain processing, and industrial know-how. That didn't happen because of a single policy, a single company, or a single breakthrough. It happened because multiple pieces moved in the same direction for more than 20 years. That's harder than it sounds. Most governments struggle to maintain consistent industrial strategies for a single election cycle, let alone 2 decades. Meanwhile, the United States spent much of that period assuming global supply chains would naturally provide whatever was needed at the lowest price. For many products, that approach worked remarkably well. Batteries expose the weakness in the assumption. Efficiency and resilience are not the same thing. The cheapest supply chain is not always the safest one. The fastest growing industry is not always located where policymakers expect it to be. And sometimes a dependency becomes visible only after it already exists. That last point matters. A lot of commentary treats America's battery push as a sudden awakening. In reality, it's closer to an emergency catch-up effort. Washington looked at the trajectory of electric vehicles, energy storage systems, defense applications, and grid infrastructure, and realized something uncomfortable. The country that pioneered much of the underlying technology no longer dominated the manufacturing. That isn't unprecedented. The United States invented many technologies that were later commercialized elsewhere. But batteries occupy a different category because they touch so many sectors simultaneously: transportation, energy, consumer electronics, artificial intelligence infrastructure, military systems, industrial machinery. The list keeps growing. If the 20th century ran on oil, there's a reasonable argument that much of the 21st century will run on electrochemical storage. Which brings us back to the title. America didn't suddenly discover lithium, it discovered dependence. There's a difference. The debate was never really about a mineral buried underground. It was about what happens after the mineral leaves the ground. Who refines it? Who processes it? Who assembles it? Who improves the chemistry? Who owns the factories? Who trains the engineers? Who scales production when demand doubles? Those questions determine power far more than the raw resource itself. And there's another lesson hiding underneath all of this. The countries most likely to succeed in the coming decades may not be the ones with the biggest reserves of critical minerals. They may be the ones capable of building complete industrial ecosystems around them. Owning resources is valuable. Owning the process is often more valuable. If I had to make a prediction, it's this: battery manufacturing will become less concentrated over the next 10 years, but not as quickly as many politicians promise. The United States will expand production. Europe will expand production. India will expand production. Southeast Asia will attract more investment. Yet China's position won't simply disappear. Industrial ecosystems rarely evaporate because a competitor announces a subsidy package. They usually remain powerful until a new technological wave arrives. And that's the real wild card. The next breakthrough might not come from lithium-ion batteries at all. It could emerge from sodium-ion technology, solid-state batteries, entirely new materials, or something sitting in a laboratory today that hasn't reached commercial scale. The companies and countries that adapt fastest will shape the next chapter, not necessarily the ones leading today. One final thought. A smartphone battery weighs only a few hundred grams, small enough to fit in your hand. Yet behind that object sits a supply chain stretching across continents, employing millions of people, directing hundreds of billions of dollars in investment, and influencing the strategic calculations of the world's largest governments. That's quite a lot of geopolitical weight for something most people recharge before going to sleep. If you enjoyed this analysis, stick around for the next one. The world's biggest shifts often begin in places that look surprisingly ordinary, right up until they don't.